Welcome to Chapter 5, Section 7, Apply the Fundamental Theorem of Algebra. The nice part about this section is it's going to be somewhat repeated. There's only a few things that are new. Unfortunately, though, it does complicate some things. All right, a repeated zero is based on multiplicity. Okay, it is zeros that happen more than once. Zeros that happen more times. What this means is we're looking at equation, here's an equation x cubed. It goes up, curves through, and goes like that. That is an x cubed. It crosses once, but that means that 0 happens 3 times. Right now we know, hopefully we know, that when it comes up, down, and up, every time it crosses the x-intercept, that's a 0. That's a 0. That's a 0. This is an x cube. It's a cubic with 3 zeros. So please also remember, we need to put in here that the degree of an equation equals the number of zeros. So what I mean by that as well, this right here, you can look at this and you know automatically that this is at least an x to the 4th, because there are 4 zeros. It's at least x to the 4th. So, the fundamental theorem of algebra. I'm going to go ahead and fill these spaces in and we'll talk about it. Okay, so I filled this out for you. Where n is greater than 0, then the equation f of x is equal to 0, meaning the zeros, has at least one solution in the set of complex numbers. Now, if f of x is a polynomial of degree n, then the equation has exactly n solutions, provided each solution repeated twice is counted as 2 solutions. It basically is what I was talking about earlier when I was graphing. Okay, I'd really like you to try to draw this graph. I'm going to show you some things here. Hold on, sorry. I'm going to try to perfect this graph just a minute. Okay, so looking at this graph, you can know a few things about its zeros. You know that every time it touches here, that there is a 0. A real 0. So these are real zeros. This part right here represent imaginary zeros. And there's a few more things you can add to this. If the line goes straight through, we're going to say then it is 1, 0. So right here, this would be 1, 0. Then, if it barely touches, if it barely touches, then an even number of zeros. If it goes through So right here, oh, sorry. So this is an even number of zeros. This is an odd number of zeros. And then the last part, okay. And lastly, if it doesn't go through, but has a weird curve, then it has an even number of imaginary solutions. All right. So that's what we're working on. Okay. Let me add in here that then this would be even. So this graph could have 1, 2, 2, 3. The degree of this graph could be 8. This could be an x to the 8th power equation. Or it could be 1, 4, 4, 5, which means this could also be a, let's see, 8, 6, a 14, an x to the 14th degree equation. There could be 14 zeros. So please keep this in mind, and we may be flipping back to this a little later. All right, so find the number of solutions or zeros. Find the number of solutions or zeros for each equation or function. Because this is a third degree polynomial equation, it has 3 solutions. Because this is a 4th degree polynomial function, it has 4 zeros. Now, something we can know about these numbers is this could be all reals, all imaginary, or it could be a bunch of individual ones. Here, checkpoint. Why don't you pause this and give it a try? You just have to say how many zeros are there. And hopefully you paused it and wrote that there are 3 zeros because of the x cubed. All right, let's take a look at guided practice number 1 and number 2. Number 1 gives us the equation. And it asks us how many zeros? Well, it has 4 zeros. Guided practice number 2. This one here has 3 zeros because of the highest exponent, the degree. All right, now finding the actual zeros. You first have to know the zeros. All right, find the rational zeros of f. Because f is a fifth degree function, it has 5 zeros. So we know there are 5 zeros out there. The possible rational zeros are plus or minus 1, 2, 3, 4, 6, and 12. Those are the possible ones. So, by using synthetic division, we're going to try to determine which ones might work. So, synthetic division, coefficients go across the top. The fifth, fourth, third, second, one, and constant. So we aren't missing any terms. We need to check some of these. So you can check all of them to see which ones work. Or you can graph it and get an idea of what the graph looks like. All right, so when I graphed this equation, it gave me an equation that looks like it came up, came up, drops down, barely touches there, and then goes back up again. All right, it looks like a cubic, but we know that there are 5 zeros. But in looking at this graph, we're going to test -1 and +2. So let's give it a try. Let's try -1 to begin with. So we drop it down. Remember, these are the coefficients. Drop it down, multiply, add, multiply, add, multiply, add, multiply, or I'm sorry, add, multiply, and we get 0. So -1 for sure. So we know -1 is a 0. And now we're going to continue with these exponents right here, these coefficients right here. And we're going to try 2. Multiply, add, multiply, add, multiply, add, multiply, you get a 0. So 2 works. But when I look at this graph, and I go back to the beginning of the video, and I see that anything that barely touches, there's an even number of zeros. So that means that this number 2 can happen again. Drop the 1 down, multiply. That 2 happened a second time. So just by knowing what the possible zeros are, just by graphing and synthetic division, I am finding solutions to this graph. I could try 2 again, because it could happen 2 more times. But now I'm gonna factor it instead. at least I'm going to see if it can be factorable. 1x squared minus 2x plus 3. Well, are there factors of 3? This is not factorable. So we can't use Waddell's method. We can't factor. Graphing, synthetic division, none of those things will help. The only thing that will help is completing the square or the quadratic formula. So we're going to jump ahead to number 3, and we're going to use the quadratic formula. We're going to use x equals the opposite of b minus 4 times 1, or minus 4 ac all over 2 times 1. Well, the first part here, this is a 2 plus or minus. 2 squared is 4. Negative 4 times 3 is minus 12. So we get the square root of negative 8 over 2. Now, if you can get to this point right here, I'm okay with it. That's pretty good. You should look at the square root of 8, though. And you know that a negative comes out as an imaginary number. You know that 8 is 2 times 2 times 2. So you pull out a singular 2, and you end up with 2 plus or minus 2i square root 2. And thankfully, our last zeros are right there. All right, that was a lot of work. I hope you found space for it. So find the complex using to factor the trinomial completely. So we found all the zeros. The zeros are negative 1, 2, 2, and then 1 plus or minus I square root 2. But the factored form tells us that each of these now make it the opposite sign, so x plus 1, x minus 2, x minus 2, and then whatever we were left over with from synthetic division. That's how this is set up. All right, so let's look at this problem right here. First of all, the possible zeros are plus or minus 1, 2, 4, 5, 10, and 20. The graph of this, so you'd grab your calculator, x to the power 4 minus 7x to the power of 3 when I graph it, it's going to look like it goes through negative 1, 4, Alright, like I said, the graph's going to come down through here. It's going to do this weird squiggly thing, like that. So, going back to the original thing, this right here, 1. This one right here, 1, 0. These little squigglies that don't cross the axis are imaginary. So that means you're going to have 2 reals, 2 imaginaries to equal your 4 total zeros. So setting up synthetic division, putting our zeros in there that we know will most likely work. So -1 works. Oh, not 20, 16. 4 works. And now we use the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. What you're going to see here, let's see here, that's 16 minus 20. That's 4 plus or minus the square root of -4 all over 2. If you get to this point, I'll be happy, but 4 plus or minus I square root 4 over 2 gives me 4 plus or minus 2I over 2, which then drops us down to 2 plus or minus I. Those are your zeros. 4, -1, and right there. All right, I'm going to do number 4 because number 3 gives you nice zeros. Number 4 is x to the 5th, which means 5 zeros. 2x to the 4th plus 8x cubed. Oh, no, not cubed, squared. Plus 6. So all the possible zeros, well, first off, there are 5 total. Possible zeros are plus or minus 1, 2, 3, 6. Now we check by using synthetic division. Oops, forgot some information here. Please, please, please do not forget missing terms. So don't forget the missing terms. Right here, there is a missing term. It's a 0. Then 8, -13, and 6. So we need to start by determining which ones are possible. So pause the video and try graphing this on your own. So the graph looks something like this. And since this goes straight through, there's 1, 0. And since it doubles, it bends here, then it's an even number. So there could be 2 or 4, or 2 or 4 of them. We're not sure. We have to find out. So let's start with the singular one. Let's put a 1 there. One works. Oh, I guess we didn't do the singular one. We did this one. Let's see if 1 works again. One works a second time. Now we could try one more time, but let's go ahead and try our -2. So negative 2 works. All right. Now we need to look at this and determine whether it's factorable, whether it can be 1 again. But what you're going to notice here is we went from an x to the 5th to an x to the 4th, an x cubed, and now we have a 1x squared minus 2x plus 3 gives me 0. And hopefully we see that we have quadratic formula, x equals opposite b plus or minus square root b squared minus 4 times a times c all over 2a. Well, that's a 4 minus 12. 2 plus or minus the square root of negative 8 over 2, which we've actually seen before, and it becomes 1 plus or minus I square root 2. That's guided practice number 4. All right, complex conjugate theorem and irrational conjugate theorem. If f is a polynomial function with real coefficients, and a plus bi is an imaginary 0 of f, then a minus bi is also a 0. This is where I said at the beginning, imaginary ones come in pairs. Suppose f is a polynomial function with rational coefficients, and a and b are rational numbers such that square root of b is rational. If a plus the square root of b is a 0 of f, then a minus square root b is also a 0 of f. It again says that any of these weird zeros, they come in pairs. All right, so I think we're almost done. Write a polynomial function of f in least degree that has real coefficients, a leading coefficient of 1, and negative 2 and 3 plus I as a 0. All right, negative 2 is the easy one. That's x plus 2. It's the opposite. Negative 2 plus 2 is 0. This one here requires the complex conjugate theorem, 3 minus I. So what it has us doing is it has, let's start off with x plus 2. And then x, well, let me do this another way. It is x plus 2, but it's really x minus negative 2. So here this would be x minus 3 minus I, and x plus 3 minus I. Okay? So all you got to do is do x minus what the zeros are. And then we have to do some multiplying. And this is where foiling, factoring will come into play. Let's do this part right here first. It's x plus 2. That's x minus 3 plus I. And that's x plus 3 minus I. And let's do the conjugates first. All right, hold on just 1 minute here. It's not, this part isn't the conjugate. This part is the conjugate. So you need to make sure it's x minus still 3 plus I. So that part is where the conjugate comes into play. So now this is still minus 3 plus I, and over here it's x minus 3 minus I. And a long time ago, when we did factoring by grouping, you hopefully can see that you have an x minus 3 and an x minus 3. And a plus I and a minus I. So what you now have is you have this old thing where we had x minus 2, x plus 2, and all you had to do was the first part, x squared, and square the last part, and you were done. So for this one, for this, that's exactly what you do. It's x plus 2, x minus 3, plus I, x minus 3, minus I. So these are conjugates. You square the first part, and you square the second part. And of course, I squared, if you remember from a long time ago, is just 1, or negative 1. All right, so we're going to do a couple more of these, but we're not quite done here. X minus 3 squared is x squared minus 6x plus 9 plus the 1. So it's x plus 2, x squared minus 6 plus 10. That's why this was not factorable. Now we distribute x cubed minus 6x squared minus or plus 10x. And then we do the next part, the 2, and we get 2x squared minus 12x plus 20. And when I combine like terms, you now have an equation that looks like this. This equation will have these as its zeros. So let's try it. All right, if we were dealing with just 1 and 4, that means x minus 1, x minus 4. And when I FOIL, I get this when I FOIL. But we also have to look at the fact that 1 plus square root 6 also has 1 minus square root 6 as a possible 0. So let's do these two. X plus, or I'm sorry, x minus and x minus, they're kind of opposites of each other. So I'm looking at this, it becomes x minus 1 plus square root 6, x minus 1 minus square root 6. And now it's a conjugate pair. Basically, it looks like we had x plus 6, x minus 6. So you square the first part. Over here it would be x squared, and then minus 6 squared. So here it's x minus 1 squared minus square root 6 squared. So there's part of your equation. And we know the other part of the equation. There you go. Now you should be able to multiply this out on your own. All right. Don't worry about Descartes' rules of signs. Try some of the other ones. Let's do guided practice. Number 5, okay? Number 5 is basically all you're going to need to do for your test and your quiz. We're not too worried about the irrational or imaginary ones quite yet. So if you have -1, 2, and 4 as your zeros, to write the equation, it's x minus -1, it's x minus 2, and x minus 4. And now it's a matter of foiling. X squared minus 6x plus 8. And then multiply this out. X cubed minus 6x squared plus 8x plus x squared minus 6x plus 8. Combine like terms. X cubed minus 5x squared plus 2x plus 8 gives me my equation. So that is about it. Try some of the guided practices, and we'll do a lot of 5.7 in class. Good luck.